Let me get this straight. You've instrumented your microservices to create your own metrics, and their values are being concurrently updated as your code executes, which is great. But you're flushing the values of these metrics into the logs? I mean, I'm not going to judge, but there are better ways for you to visualize those metrics. I'll tell you what, in this video, I'm going to show you how to configure the OpenTelemetry collector to send the generated metrics into Prometheus, which is a time series database, so you can use Grafana, for example, to visualize these metrics in a more visual and appealing manner. Let's do it. Hello there and welcome. My name is Ricardo Ferreira and I'm a developer advocate here with AWS. This video is going to be focused in showing you how you can configure the OpenTelemetry collector to send the generated metrics that you've created by instrumentation to compatible observability backends. Specifically, I'm going to show you how to store the generated metrics in Prometheus, which is a time series database, and then you can use Grafana to visualize those metrics. Before we move forward, just a heads up that this code that we're using for demonstration purposes can be found on GitHub. If you look in the comments below, you're going to find a GitHub repository that contains the implementation of this microservice written in Java. When you clone that repository, use that specific branch called Build on AWS tutorial. Now, to wrap up the last video, we've created manually two metrics that are responsible for monitoring the number of times the microservice executes. And this was created using a static metric. And then we created a synchronous metric that computes the amount of memory utilized by the JVM heap. So these two metrics are being currently generated as the microservice executes. So our job now is to tell the OpenTelemetry collector to grab those metrics and send to Prometheus. So this will require you to change not only the OpenTelemetry collector, but your Prometheus configuration. Starting with the collector, we need to include another exporter. So this exporter, for obvious reasons, we're going to call Prometheus. So I'm going to put them right here. And as you can see here, there's this variable called endpoint that is going to have the value set for the host name of the collector and a port exposed by the collector 6666. Now, you might be wondering where this port is coming from. So in the previous videos, specifically in the part where I've showed how to implement and configure the OpenTelemetry collector, we have created an entry in the Docker Compose file that actually rebinds that port from the collector to the outside world. So if you look to the Docker Compose file right now, you're going to see that the collector actually exports two ports. The first one is 5555, which is the port that the collector is exposing the OTLP protocol, as you can see here. So it's going to receive all the telemetry data using OTLP on this specific port. And we're also rebinding this port 6666 that at this point hasn't been created and used so far. Now is the time for the collector actually expose that port. Now, the way Prometheus work, it doesn't necessarily expect you to push metrics and data to Prometheus. It does a process of what we call scrapping. It means that Prometheus proactively go search for a specific value for metrics in a given endpoint. So that's why your collector is not necessarily pushing data to Prometheus. It's going to expose an endpoint. So you can read this as your collector effectively exposing an endpoint over the port 6666. And Prometheus needs to come here and scrap the values of the metrics. That's why I've said before that you might need to change your Prometheus installation and configuration. And this is what we are going to do right now. So in this code that you've picked up from the GitHub repository, you're going to see that there's a folder called Observability Backend. And if you expand that folder, you're going to see that there's a file called prometheus.yaml. So open this file, and here you're going to find the global configuration about the interval where Prometheus is going to be scrapping data. This is the global configuration, but you can actually include your own configuration, and this is exactly what we're going to do right now. we're going to include a custom configuration of scrapping that's going to tell Prometheus to create a job called collector, and could be name it something else, and every 5 seconds is going to scrap metric information from this endpoint collector and over the port 6668. Just to recap, who is this port? It is the port that is going to be now exposed by your OpenTelemetry collector. So now that we've provided a way for Prometheus to scrap the endpoint, and now we have defined the endpoint that will be exposed to Prometheus, now we can actually use this exporter in the actual timeline. So what we're going to do now is include this exporter in the service pipeline implementation for the metrics. So you don't need to change any receiver. It's going to continue to receive over OTLP. But when it comes to export the generated telemetry data, you are going to actually just append another exporter. So what is the reading here? Now the collector, every time it needs to flush information about metrics, is going to flush both to the login and to Prometheus. Internally, that means that Prometheus is going to basically is going to make all the values from the metrics created available on that endpoint that the collector is exposed. By the time Prometheus go there every 5 seconds and scrap that information, it's going to collect the updated values of the metrics. Now, we can go back now for the our implementation, and we're going to now spin up both the observability backend that includes the collector, and we're going to re-execute the microservice to see if this configuration is working. So let's start by spinning up the the backend, observability backend. So if it's running right now, you can restart the observability backend so it can actually pick up the new information both from the collector and from the Prometheus. So, and if not, you can simply docker compose up, and then you can use the parameter -d so the containers can be running on the background. So now we are spinning up the Prometheus time series database, Grafana temple, which is going to be used for holding the traces, and Grafana as the visualization tool, along with our OpenTelemetry collector. So let's see if the containers are up and running, and they are. Everything is up and running and healthy. So now we can actually start our microservice. And once the microservice starts, we're going to send some requests to it so we can actually go to the observability backend and visualize the metrics created. So the microservice is up and running, as you can see right now, and I'm going to create a new terminal to send some requests to the microservice. So I'm going to pick up from the history here. So I'm going to send 1, 2, 3, 4, 5, 6. By the way, let me know in the comments below, when you are testing your microservices or code, how many requests you actually send to it for testing purposes? 1, 2, 100. What I've noticed is that everyone has their own number for like psychological testing overdue, except of course when you were load testing, so you have to send a bunch of them. But I've been always curious to learn how many requests people send to the microservice. I have the tendency to send both 2 or 6. That's kind of my magical number. So let me know here in the comments below what type of number you use. So now that we have sent 6 requests to 6 requests to the microservice, let's jump to the observability backend to see if the metrics has been not only created, but those values reflect that. So see you in the Grafana visualization tool. Like Matthew McConaughey likes to say, all right. Now is the time we've all been waiting for. We're going to use the observability backend to visualize the generated metrics. So now that we're back here in Grafana, we can use the option Explore, and then you're going to find that in this drop box here on the top, you're going to see 2 data sources, one from Grafana temple and the one for Prometheus. Pick the Prometheus ones, and then you can use this option called Metrics Browser to list all the metrics that has been scrapped by Prometheus. And you're going to see that there will be a bunch of them because the OpenTelemetry agent for Java automatically creates some of them for you during the automatic instrumentation process. But you are going to see the 2 of them that were the result of the manual instrumentation that we have done in the previous parts of the series. So we've created this metric called custom metric number of execution and custom metric heap memory. So to investigate this number of executions, select that metric, and then you can click here on use query to start visualizing the value of that particular metric. So even if you change the chart type of this metric, you're going to see that the value itself and the appearance of that graph is not going to be so exciting because this is a monotonic metric. It means that only increments. So you're not going to see like a bursts of increments or decrements on this value, but you can always scroll down to the bottom of the page and you're going to see this table over here that shows you the current value of that metric. And as you can see here in the bottom, the current value of this metric is 6. So is this a coincidence? No, this is not a coincidence. This is exactly the number of times that we've executed the microservice. So the value of this approach of creating your own metrics, one of them is to create this type of metrics that mimics a little bit better what is the current reality of your code. So as you can see right now, we can actually provide to the observability team a more concrete way to actually understand the current state of what the code is doing. So you can use the same approach to visualize the amount of heap utilization for that microservice. So you go back to the metrics browser, and then now you can select the metric heap memory and click again on use query. So since this is a non-monotonic metric, you can see that the graphic itself is more exciting because you're going to be able to see increments and different fashions. And when the garbage collector for the JVM executes, for example, you might be able to see not only the increments but decrements because the garbage collector will eventually make room for more space in the JVM here. And as you might have seen in the previous metrics, if you scroll down to the bottom of the page here in Grafana, you're going to be able to see the current value of that metric. Now that you've seen how easy it is to create your own metrics and to configure the collector to send the telemetry data generated to the compatible observability backends, I would highly encourage you to explore that practice because this is what we're calling as the future of programmable observability. The OpenTelemetry project provides you with the support you need to create your own metrics, your own traces, or any other signal types that in the future is going to be supported by the OpenTelemetry project. But there's one specific characteristics of OpenTelemetry that is arguably one of the most popular and sexy ones, which is the ability for you to implement this programmable observability in the vendor-neutral fashion. So what that means, it means that right now, for example, we've used Prometheus for storing the metrics, and we've used a Grafana temple for storing the traces. But what if we would like to change the observability backend? Would you have to change the whole implementation that you have done, both using the automatically and manual instrumentation? The answer is no. And in the next video, I'm going to show you how you can actually accomplish this switching of the observability backend without touching in a single line that you have done so far in this series.
Hey there! Thanks for checking out this video. Remember to give it a like and share with your community. Then hit subscribe and the bell for all the latest content that will help you build on AWS.